So we have done with BGP. Now we are into another topic called quality of service. Quality of service. Quality of service. We can also call it as queuing of service. I always repeat this word many times. Queuing of service in my QoS trainings. So even in this training, I use the same word, queuing of service. Say for example, you are standing in a big queue in the airport ticketing section. You are trying to check in, and you are in a very big queue, where let's say 300 people are standing there in the queue, and you are 301 guy. You are in 301th person, and you got 300 people, and in another 30 minutes your flight is going to take. It's going to take off in 30 minutes. Now you got 300 people and you got only one counter for check-in. What will be your condition? Instead of standing in the queue, better you can go and sit somewhere. Anyway, you are not going to make in half an hour. You are not going to check in half an hour, and in half an hour you have to check in, do the security check, and then go to the gate, and then getting into the plane. Not possible in 30 minutes. So what you need is, you need a special service. You need someone to call out for your name. Hey, anyone going in this so-and-so flight, which is going to start now in 30 minutes? Anyone is there? And someone you want to call you friend and put you in the queue, the front of the queue, and provide you the ticket. That's what you are expecting. Only then you can fly in that aeroplane. You want someone to call you from the back of the queue and put you in the front of the queue so that you will get the ticket and fly immediately. If not, what happens? You lose the flight. That is what QoS does. Quality of service is also the same. You got some traffic which are time sensitive. Now, every device have got a hardware queue and software queue. Let's focus on the hardware queue first. Every port on the router, every port on your switch has got a queue, which is hardware queue, and which works by default as FIFO, first in, first out. Any traffic that goes inside the queue first will be served first. But the problem is, there is a packet at the 301th packet which wants immediate attention. If it is not given immediate attention, if the packet is not allowed to go out, maybe the packet may get expired. It's a time sensitive packet like voice and video. So I'm talking to you and you are hearing me. The reason is my packet is prioritized. That's the reason why you got the synchronization. You can hear me continuously. If my voice packets are delayed somewhere in the path, you will get a lot of drop in my voice, sometimes jitter. You used to tell me, you sound like a robot. Why it is like that? It's because of jitter, the drag, the delay in the delivery of voice packet. Sometimes even you will not hear me. Sometimes when you speak, I don't hear you. What happens? You are speaking actually, but the packet gets delayed and expired and get dropped in the path because we are thousands of miles away. It's very common when we have a poor internet connection and poor service providers in the middle, where there is no proper quality of service has been deployed. So if you put the voice packet, which is time sensitive, from the back of a queue into the front of the queue, then you can solve the issue. Packets will reach on time and the receivers will not have any break or any jitter or any drop in the voice signal that they receive or in the video signal that they receive. You are seeing my video now without any disconnection. The reason is these voice packets, video packets, they are all served, they are all prioritized, they are all kept in the front of the queue, even though they are not supposed to be in the front. Though they come late, they are kept in the front of the queue. They are prioritized between you and me on all the devices in the middle. Because they are prioritized, you can see my screen and you can hear my voice without any break. Doing this is what called as quality of service in networking. Prioritizing the packet, putting the time sensitive packet, important packets like management traffics in the front of the queue is what called as quality of service. See, EIGRP sends hello packets. If you miss hello for 3 cycles, if you miss 3 hellos, what happens? EIGRP will discard the neighbors and throw all the routes from the routing table. So you need to make sure that EIGRP hello packets are not delayed. If they are delayed more than 15 seconds, what happens? You discard the neighbor. You disconnect the neighbor. You throw the routes given by the neighbor. And you start changing the routing table according to the current update. So, they are all time sensitive. They need to reach on time. The hello packets of OSPF, hello packets of EIGRP, updates from BGP, they all need to reach on time. If not, there will be a big mess in the network. They're all management traffic. They need to be prioritized. If they are not prioritized, then network will be in a big chaos. That's where quality of service comes into picture, to prioritize those important time sensitive management traffics. Any question up to this level? Alright, so now let us get into QoS and see this is what Agenta is. Let's keep going. Yeah, what is QoS and why do we need it? I already explained you with a nice example. And here we have another example. What is QoS? It's a quality of service. What problem it solves is very important. During the time of congestion, see the first point, the last 3 words, during the time of congestion. That's very important. See, you are standing in the airport in a queue and someone calls you to come to the front. Not all the time. Only during the time of congestion. See, you have only 30 minutes for the flight and you got 300 passengers. Congestion. 30 minutes, time critical. It's time sensitive. Only during that time you got that special service, someone calling you and asking you to go in front. That will not happen every time. If there is only 5 customers standing in the queue, they might have not called you. So, same thing even here. Whatever the quality of service that we configure, that will be effective only during the congestion time, not all the time. So, provides a predictable management of network resource during the time of congestion. So, if congestion happens, if more congestion happens, it provides what will be the next. It will not, it will not put you in dilemma. It will not put you, I don't know what is going to happen. When the congestion happens, you will be very clear that voice traffic, video traffic, EIGRP, hello packets, OSPF hello packets, BGP, all this will be fine. Maybe some FTP packets may get lost. but because it is TCP, I can recreate it. I can request and send it. I can request to send it again. So you can easily predict how the network is going to be during the time of congestion. It is because of QoS. If you don't have quality of service, then you don't have idea which packet is getting dropped. You don't have an idea whether voice packet or video packet or EIGRP updates, OSP, you don't know what is getting dropped. But if you have a quality of service, you can prioritize all those voice packets, video packets, all those hello packets, updates. And you can very clearly say that my network will be still up and running because I have prioritized all the management traffics. And you can very clearly say that my video conferencing will not get disturbed because I have prioritized my voice and video traffic. So you can easily predict. It's a predictable outcome during the congestion. That's what quality of service provides. Sometimes, let's say, you got stuck in an airport and there's supposed to be 5 flights in next 3 hours to India, but for some reason 4 flights are cancelled and only 1 flight is going to fly, but there are passengers there for 5 flights, but only 1 flight is going to fly. So what the quality of service need to be done there? Immediately they will call all the business passengers of all 5 flights and they will put inside 1 flight and they will send the business class people first. And if there is some space, and they will find the family with small children and they will put inside the flight, and they are safe, they are sent first. This is what this is another quality of service example. So you don't keep all the five flight passengers staying in airport and struggling there. You send all the older people, business people, children, everyone in the only 1 flight that is available, and the rest will be staying in the airport for another day to come to take them. That is again another good example for quality of service. Same thing happens in the networking during the critical time, during some congestion, unexpected congestion. If always congestion is happening, then your design is not good. You need to change the design. Design is not good. But congestion happens now and then. Sometime, not every time. Sometime, not frequently. Sometime it happens. Seldom it happens. Then you can go for a quality of service solution. So even during those unpredictable congestion time, you can have a predictable network resources, and it is taken care by quality of service. It also assists in maximizing the end user experience of critical session. That's what I was telling you. You are having a good conference, voice and video conferencing, and that is a critical session. Now you can very clearly have very good audio and video all the time when you do quality of service, when you prioritize those time sensitive traffics like voice and video. Or let's say you have a very important application, your company application, that is sending packets over the internet, and that application is the one keeps the database updated. So that application traffic has to be prioritized. That is very important traffic for your company. So what you do is you prioritize it so that the end user, the company, will be happy. See, that traffic should not get dropped. Say for example, you got a lot of ATM machines, and you got a lot of employees working in bank. and you got a lot of employees working in the customer care wing of the bank, and you got different departments in bank like this. Now there are some people who play online from the bank, sitting inside the bank, they play online. There are some people who download some traffic, some big file from the internet. There are some people who simply surf internet. Maybe they are looking into the what? They are looking into Facebook. They are just moving the pages in Facebook up and down. Lot of memories, lot of download happens. Lot of bandwidth is consumed because of Facebook. So same time, the database is also getting updated. See, I go to one ATM and I take money. Immediately it has to be updated. If it is delayed, what will happen? I'll go to another ATM and say take the same money. What do you understand from that? It's a time sensitive packet. It has to get updated immediately in the bank database, so that the money will be maintained correctly. If I withdraw, I got only 10,000 rupees in my account. I withdraw 10,000 from one ATM, and if it is not updated immediately, I'll go to another ATM and take the same 10,000 again. That's very dangerous, right? So it has to be updated immediately. Though it is not a time sensitive traffic with respect when you compare to voice and video, but still it is time sensitive because it needs to get updated. The bank need to get updated with the latest withdrawal transaction detail. If not, big problem. So it assists in maximizing the end user experience. Now end user experience is very good here because it updates. The critical sessions happen on time. They are not delayed. And also with the help of quality of service, we can predefine the user critical packets as the more prioritized one. That's what we were talking now. Though we got many different types of traffic, Facebook traffic, file transfer traffic, normal file transfer, surfing Google, surfing Gmail, Yahoo, and also the transaction detail in the bank. So out of this, which you give more priority? You give more priority first to the management traffic, and next to this transaction traffic, the traffic that happens because of someone doing transaction in ATM and also in the money counters. Now what you do is you match those packets, the transaction packets, and give it more priority so that the update will reach the database faster, and the bank's database will be up to the mark. It will be updated on time, so that there won't be any confusion in the the balance amount or the available amount for the withdrawal. Is there any question in this? Next is how does QoS provides those services? Now we were talking about a lot of services. How the quality of service work, how it can provide the best service that we are expecting. See, the hardwares like switches and routers, they don't understand what is there in your mind. They don't understand your company policy. So it is we, the network administrator, need to make the box to understand. We need to tell the box which traffic is more precious than the other one. We need to tell them what to be given more priority during the congestion time. We need to tell our switches and routers, if congestion happens, these packets you can drop it. I have no problem. So that you can bring the network to normal condition. So we can tell our devices how to behave during the congestion time to bring back to the normal. So we will have a lot of things in our mind. Okay, if FTP traffics are getting dropped, we can recover it. So we have no problem in getting dropped during the congestion time to reduce the congestion, to bring it back to normal. I don't have any problem if HTTP packets are getting dropped. So these are all in your mind going. So you need to tell your router, you need to have some way to tell the router that do this during the congestion time. Drop all these packets. I don't have any problem. Bring the network back to normal by dropping these packets, or you can mark some packets. These packets are not time sensitive. They are not time sensitive. So you can mark these packets and delay these packets. Delay it, no problem. Delay it. Allow other packets first. Delay these packets so that not all packets are going to try at the same time and getting congested. So in order to avoid congestion, you can say these packets, I have no problem even if it is delayed. So when you do that, what happens? The other packets will have enough of bandwidth, enough of room in the pipe, in the hardware queue to go out. If all tries the same time, then only congestion happens. It is like, in India, during the working hours, like from morning, I think 9 o'clock till evening 9 o'clock, no lorries are allowed inside the town. Cities like Bangalore, Chennai, and many more cities, they don't allow big lorries to come in. They are delaying. They say, hey, stay outside the city, but do not come in. Don't come inside the city during this 9 to 9, morning 9 to evening 9. You can come after 9. So what they are doing here is they are marking the packets and delaying those packets to avoid congestion inside the city. Inside the city, they don't want the school going vans and buses and the office going people to get disturbed or get delayed because of these big lorries coming and making more congestion. So to avoid congestion, they do this. That's what called as marking, and marking the packets and delaying them. Likewise, we have a lot of techniques to do this. Let's see one by one. Many different QoS features we have. Some designed to accomplish a particular task. Some are for multiple tasks. In general, the tasks that quality of service feature can accomplish can be categorized as classification of data. That is what I was telling you. You classify the data first, meaning, you identify the data and then classify it. You tell what is there in your mind to the router. What is there in my mind? My mind says voice packet has to be given more priority. Google Hangout has to be given more priority. So what you do is you tell the router, match this Google Hangout. If the match happens, give this much of bandwidth percentage. This much percentage of bandwidth. Or put them in this fast lane or high priority queue. Put it in a high priority queue. You create more queue. High, medium, low. Put it in the high priority queue. So that is what classification helps you to do. Classify the data. There are various type of data. You have management traffics like EIGRP, hello packets. You got email, someone chatting, messenger. You got voice traffic, video traffic. You got some file transfer, FTP traffic. You got SSH. You got telnet. You got various types of traffic. Classify them first. So we can classify the data, and then we can provide the size of the queue. We can place the packet in the front of the queue, or we can have a scheduling. We can have we can have some scheduling. We can say when this packet has to leave, how much the priority need to be given to this packet. We can also say the transmission rate, how many packets can go and how much of bandwidth it can consume. What if it goes more than that? How many packets need to be dropped? That's what preemptive drops. And also we can have a marking of the packet so that we can treat the packet based on the marking that we do. So by doing all this small technique, by having all this technique, we can have a very good quality of service in our network according to our desire. So quality of service has to be done on both routers and switches. See, when we talk about the router, everything happens on CPU. Everything happens on CPU. Router is software based. Everything is software based. The control plane is software based. Everything is software based here in router. Whereas in the switch, we have a lot of hardware based chips. ASIC, application specific integrated circuit, which decides on forwarding. The forwarding decisions are done by hardwares. So it's not the same way that happens in router on the switch. It's different. So what happens is on the router, the packets are received on the ingress interface. What is ingress interface? The interface where the traffic is coming in. See, we have a router here, let's say R1, and we got a serial interface connecting to the internet, and we got many LAN interfaces, F00, F01, F1/0. Now we got 3 interfaces. So what happens? The packets are arriving on the ingress interface. On the ingress interface, and then they're placed in the memory buffer. Each interface has got a memory buffer. They're placed inside the memory buffer, and then they go into the routing decision, that is forwarding decision. The control plane, the CPU process it, and all the packets want to go online. So all the packets are kept inside this transmitting buffer. They're placed on the hardware transmitting ring. They're the packets from here. They're kept in the outgoing interface ring, and the packets are transmitted one after the other. See, from this diagram itself, you can easily guess what makes the congestion here. Multiple inputs going on one single output interface. More congestion happens. So we need to do some good quality of service here. So there is need for a good quality of service on the egress interface. We need a good quality of service on the egress interface. This is egress interface.